Mercury's magnetic field. Mercury has a magnetic field that is about 1% as strong as Earth's magnetic field. This magnetic field is thought to be generated by the planet's core, which is composed of a large amount of iron and other metallic elements. Like Earth's magnetic field, Mercury's magnetic field is thought to be generated by a dynamo effect, in which the motion of electrically conducting fluids in the planet's core creates a magnetic field. Mercury's magnetic field is unique among the planets in our solar system, as it is tilted at a significant angle relative to the planet's rotational axis. This tilt creates a complex and unusual magnetic field that is shaped by the planet's rotation and its interaction with the solar wind. Because of its weak magnetic field, Mercury is more susceptible to the effects of the solar wind than Earth and other planets with stronger magnetic fields. The solar wind, which is a stream of charged particles flowing from the Sun, interacts with Mercury's magnetic field and can cause the planet's magnetic field to fluctuate and even disappear temporarily. Scientists continue to study Mercury's magnetic field in order to better understand its structure and dynamics, as well as its relationship with the planet's interior and the solar wind. Recent data from NASA's Messenger spacecraft has provided new insights into the planet's magnetic field, including its complex and dynamic nature. One of the most unusual aspects of Mercury's magnetic field is its orientation relative to the planet's rotation. While the magnetic fields of most planets are roughly aligned with their rotational axes, Mercury's magnetic field is tilted at an angle of about 11 degrees relative to the planet's axis of rotation. This tilt is thought to be caused by the planet's interaction with the solar wind, which exerts a force on the planet's magnetic field and causes it to become twisted and distorted over time. Another unusual feature of Mercury's magnetic field is its variation over time. Scientists have observed that the planet's magnetic field changes in strength and orientation over time, and can even disappear entirely for brief periods of time. These changes are thought to be caused by the planet's complex magnetic field geometry, which can lead to instabilities and fluctuations in the field's strength and direction. Despite its relative weakness, Mercury's magnetic field has a number of important effects on the planet's environment. For example, it helps to protect the planet's atmosphere from erosion by the solar wind, which can strip away the atmospheres of planets without magnetic fields. The magnetic field also interacts with charged particles in the planet's environment, creating a variety of interesting phenomena such as auroras and plasma waves. Overall, Mercury's magnetic field is a fascinating and complex feature of the planet, and continues to be the subject of intense scientific study and investigation. By studying the planet's magnetic field, scientists hope to gain a better understanding of the planet's interior structure, its interaction with the solar wind, and the processes that shape the evolution of planets and other celestial bodies. Mercury's magnetic field is much weaker than Earth's magnetic field, with a strength of only about 1% of Earth's magnetic field. This is likely due to the planet's small size and relatively slow rotation, which result in a weaker dynamo effect in the planet's core. Despite its weak strength, Mercury's magnetic field has a number of interesting properties. For example, it is highly asymmetric, with a much stronger field in the northern hemisphere of the planet than in the southern hemisphere. This asymmetry is thought to be due to the planet's unusual magnetic field geometry, which causes the field lines to be more tightly packed in the northern hemisphere. Mercury's magnetic field also has a significant impact on the planet's exosphere, the thin layer of gas that surrounds the planet. The magnetic field interacts with charged particles in the exosphere, causing them to become trapped in the planet's magnetic field and creating a region of dense plasma known as the magnetosphere. This region is similar to the Van Allen radiation belts that surround Earth, and can have important effects on the planet's atmosphere and surface. In addition to its asymmetry and impact on the exosphere, Mercury's magnetic field also exhibits a number of interesting temporal variations. For example, the strength of the field can vary over time, and the field can even disappear entirely for brief periods of time. These fluctuations are thought to be caused by the complex interplay between the planet's magnetic field and the solar wind, and are the subject of ongoing scientific investigation. Overall, Mercury's magnetic field is a fascinating and complex feature of the planet, and studying it is helping scientists to better understand the dynamics of planetary magnetic fields and their impact on planetary environments.